This is part 2 of section 2.3, and this will help you. The information we talk about right now will help you with these problems 1, 2, 6, 10, 11, 13, and 15. So these problems in section 2.3. So, and these problems all have to do with the other trig functions. So we already talked about the derivatives of sine and cosine. Derivative of sine is cosine, and derivative of cosine is negative sine. And so right now we'll talk about the other 4 trig functions. So tangent of x, cotangent of x, cosecant of x, and secant of x. So before we do that, though, I want to do this problem. It's a good problem because it practices both the derivatives of sine and cosine. And it also gives us a chance to practice the quotient rule again. So just a reminder from earlier that from the part 1 video, the quotient rule just says that the derivative of a quotient, so where you have one function divided by another function, is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. And this right here is referred to as the quotient rule, if I can box it. I'm going to pause this while I box this. So this is called the quotient rule. And so we're going to practice using this. We're also going to practice using the derivatives of the first 2 trig functions. So the derivative of sine is cosine. Oh, I have to get new styluses. And then the derivative, I'll pause this while I write this. So what I was trying to write is that the derivative of sine of x is cosine of x, and derivative of cosine of x is negative sine of x. And so we're just going to practice using these rules, these 3 rules right here, by doing this example. So we're going to find or differentiate. That just means find the derivative of this function, sine of x over cosine of x. So we're going to find the derivative of y equals sine of x over cosine of x. Notice that this is a quotient, so we will be using the quotient rule. And just a reminder with the quotient rule, if this is your first time working with this rule, or like you're new at this, what you want to do is like identify your numerator. So like you see a quotient, you're like, okay, I have a quotient. That means I have some function over another function. So identify your numerator and just refer to that as like your top function, or f. And then identify your denominator as your g. So we'll call our cosine of x g. My goodness. So from here, and then from here, we'll like get all of our pieces and put them together. So if we know that in this situation, we're calling our we're saying our f is sine of x, then we know that our f prime is cosine of x. And if our g is cosine of x, we know our g prime is negative sine of x. And now we have all the pieces to use the quotient rule. Because notice the quotient rule, it has an f, it has a g in it, it also has an f prime in it, and it also has a g prime in it. So we have all the pieces that we need. And so now we're going to go ahead and say our derivative, y prime. Give myself a big fraction bar because I'm using this quotient rule. And notice it starts with starts with f prime. All right, so I'm gonna start with my f prime, which is cosine of x. This right here. There's my f prime. And then next comes times g. So my g is cosine of x right here. And then I have a minus. And then next I have my f without doing anything to my f. So that's sine of x. And then this is multiplied by my g prime, which was negative sine of x. I actually had enough room. From here, you want to divide by whatever your g is squared. So whatever your denominator is, square it. So we'll have cosine squared x. So just a little note that cosine squared x. So typically when we square trig functions, typically we will write cosine squared x. So just a little note, we'll like put the square between the last letter and the x. So this is the same as, this is so annoying. I apologize for my stylus problems. This is the same as, first thing I'm gonna do today is get myself some new styluses. After I'm done with work, that is. So what I was trying to write is this right here, that cosine squared x is the same as cosine of x squared. And we typically write it that first way right there. So just FYI. So now we've basically used the quotient rule. And if you were turning this in for homework, it would be fine to enter the answer this way. But I want to go ahead and simplify this one because I want you to notice one thing. Or you might have already noticed this, that sine of x over cosine of x is the same as, like, that's how tangent of x is defined from trigonometry, right? Tangent of x is sine of x divided by cosine of x. And so what we're actually doing is we're finding the derivative of tangent. And so I'm actually showing you a proof that the derivative of tangent is what we're about to see what it is. So this is actually a proof. And actually what we're doing right now, this is the first rule that will not use, like all the other rules that we've talked about so far, like the proofs, like they use the definition of the derivative, the f of x plus h minus f of x over h, taking the limit as h approaches 0. So all the other proofs use that definition. But this one, since we have the quotient rule now, whose proof uses that limit as h approaches 0 of f of x plus h minus f of x over h, that the quotient rule uses that. But now that we have that quotient rule and we have the derivative of sine and cosine, and those proofs also use that limit as h approaches 0 of f of x plus h minus f of x over h, like all of those use that definition. But this one, because we have those rules now, we can use the quotient rule to find derivatives of tangent, cotangent, secant, and cosecant. And so I'm going to go ahead and simplify this so we can get our derivative. And this is so annoying. I apologize. I'm just like so annoyed with this. So I know cosine of x times cosine of x, that's the same thing as cosine squared x. And then sine of x times sine of x is sine squared x. And notice we have a double negative. So we have a negative here and a negative here, which means I'll have cosine squared x plus sine squared x. And this is all over cosine squared x. And then you might remember from trigonometry, this identity, it's called the Pythagorean identity. cosine squared x plus sine squared x is equal to 1. This is called the Pythagorean identity from trigonometry. And so we can say, is using that Pythagorean identity, that all of this is actually equal to 1 over cosine squared x. So, and then go back to more trig and remember that the definition of secant is 1 over cosine. So what we have here is we actually have 1 over cosine times 1 over cosine, because we have cosine squared x, which means that we actually end up with secant squared x. And this is actually the derivative of tangent. So, and that's a new differentiation rule. The derivative of tangent is secant squared x. Oh my goodness. Ugh. Okay, so this is what I was trying to write, that the derivative of tangent is secant squared x. And just going through that same process with all the other trig functions, you can get the other rules for derivatives, because like we know that, for example, that secant of x is defined as 1 over cosine. So you can use the quotient rule with this and think of your numerator as 1 and then your denominator as cosine of x, and go through the process and get the derivative of that. And then you can do the same thing for cosecant of x, because cosecant is 1 over sine. And you can go through that same process. Be like, okay, my numerator is 1, my denominator is sine, use the quotient rule. And you can do the same thing with cotangent. With cotangent. You can recognize that the numerator for cotangent is cosine and the denominator is sine, and then once again use the quotient rule. So just going through that with all of the other trig functions, you get all of the other trig rules. And I'm just gonna write out all of the trig rules right now, just because I think writing it out in the way I'm about to write it out will help you memorize these, which I strongly recommend if you intend to take calculus 2, calculus 3, please memorize these. It'll make your life, possible. I think I've said that before. And yeah, it'll make your life a lot easier if you memorize them for this class once we get to like chapters 3 and 4. So just FYI. So so I'm just going to write out all 6 trig function rules. So these first 2, the derivative of sine is cosine, and the derivative of cosine is negative sine. So there's the ones that are from last week. And then the one that we just went over is the derivative of tangent is actually secant squared x. Oops. And the derivative of cotangent. So here's the thing that makes it kind of like easy to memorize. Notice that the derivative of sine is cosine, and the derivative of cosine is negative sine. They basically like the signs end up being like the sign for the cosine ends up being negative, right? For the derivative of cosine ends up being negative. And then you basically have, for its derivative, you have whatever this is without the co in front of it. So like derivative of sine is cosine, but derivative of cosine is just negative sine without the co. So if we think about like kind of that difference, when we look at like the derivative of tangent is secant squared x, derivative of cotangent also has a minus, and notice the secant doesn't have a co in front of it. So the derivative of cotangent is cosecant squared x. That. And then last pair, the derivative of secant x is secant x tangent x. And the derivative of cosecant x, see if you can guess it. You can pause, see if you can guess it. And it's going to have a minus again. So like notice all the co-derivatives have minuses, and then just switch these. So notice secant doesn't have a co in front of it. So you will have cosecant x. Tangent also doesn't have a co in front of it. So we have cotangent x. And those are the differentiation rules for the 6 trig functions. So notice they kind of like come in pairs, which, oops, didn't mean to do that, which will make it, I think, not so difficult to memorize. So memorize these and let's practice them right now. Let's look at problem number 2. Actually, we can just do this right here, number 2, because there's no, there isn't any kind of quotient rule that we have to use, and there's no product rule or anything. So we can, it's kind of a straightforward one, this one. So let's go ahead and do this right here. So if you have a constant, just bring your constant down, like a constant times a function, bring the constant down and multiply by the derivative of that function. So we know the derivative of cosine is negative sine, oops, x. They open up parentheses, so make sure you close those parentheses. And then I have minus 4, so I bring down that 4, and the derivative of tangent we know is secant squared x, and they open up parentheses, so make sure you close them. And that's it. That's the derivative. We're done. For the second part of this problem, you can do what I did in the last problem, which is, in the first video, part 1, which is copy and paste this stuff and replace all of your x's. So notice like what's inside the parentheses. Like this is saying find f prime of 4 pi over 3. So you want to recognize, oh, I have a 4 pi over 3 inside the parentheses. So that's what I need to plug in for all of my x's. So I'm replacing all of my x's with 4 pi over 3. You can just type pi to put pi in, or you can do 4 and then click on pi here over 3. And it'll accept this answer. If you want to get more detailed, you totally can. You can like figure out what your sine of 4 pi over 3 is. So like if you go to the unit circle, and then notice where 4 pi over 3 is located And remember that sine is the, so here's 4 pi over 3. And then remember sine is the y value. So this is telling us that sine of 4 pi over 3 is negative root 3 over 2. And so, and then secant, I think secant was the other part of our problem. So, and secant is 1 over cosine. So you can replace the secant with, and cosine is the x. So cosine is negative 1/2 here. So you can replace that secant with negative 1/2. Or sorry, 1 over negative 1/2, because secant is 1 over cosine. So if you want, you can use these to get a different representation of your answer, but it's not necessary. Let's look at another problem, one that requires more work. Number 6 is a lot. The reason I'm saying number 6 is a lot is because notice that you have 2x squared times tangent x over secant of x. So the reason I emphasized those words times and over is because the times part tells us we have to use the product rule. And the over part tells us we have to use the quotient rule. So let's go ahead and do this one. I'll write it down in my iPad. So first thing for this problem, so once again, like notice that you see that it's a quotient, that's you see that right away, right? So the first thing we're gonna do here is apply the quotient rule. So what we did in the very first example using the quotient rule in this video. So I'm gonna like circle this and identify this as like my F. So what I said in part 1 lecture for section 2.3 is don't worry about the fact that this says F over here, like just kind of ignore that and think, okay, I'm dealing with quotient rules. So I'm going to think of my numerator as my F and my denominator as my G. F over G. So just FYI, FYI. So where should I write this? I guess, do I have room? I'm wondering, do I have room? You know, I'm gonna write it kind of below. I'll write it down here. So my F is 2x squared tangent of x. And then my G is my denominator. My G is secant of x. So I keep kind of like all of my styluses, I guess, are a mess right now. So I just keep switching and one will work nicely for a while and then it becomes bad and so on. But so I have my F and then I have my G, and my G prime, I can find that easily, right? Like we just talked about how the derivative of secant is secant x tangent x. So that's not a problem finding my G prime. And this secant x tangent x. Now my problem comes with finding my F prime because here we have a product, which means we have to use the product rule. The product rule says that if you are, where can I write this? I guess I'll just write it down here. Product rule is saying that if you're multiplying two functions, so if I have F times G, the derivative of that is F prime G plus F G prime. So I need to like identify in this case. So again, this is the product rule. And I need to identify my F and my G in this situation. So within this situation, I'm going to have like an F and a G. So So again, ignore the fact that you see an F here, although we won't ignore it later, but for now, just kind of ignore it and be like, okay, what two functions am I multiplying? I'm multiplying a 2x squared. So let's think of that 2x squared as our F for the product rule. So our F here is 2x squared. And then we'll think of our tangent of x as our G for the product rule. What's a fun color? Let's use, I kind of like this color. I don't know how you would describe it, but I like it. So this will be our G, tangent of x, within the product rule. So now I find my derivative of my F, and I'm going to use the power rule. So I bring my exponent down. 2 times 2 is 4. And then I have x. And now I will find my derivative of my G, which is really, we don't have to worry about, because we have derivative of tangent is secant squared x. It's right here. So I get to put secant squared x here. So are you all seeing like the benefits of like memorizing these rules as you go? Because really doing the homework for like each section each week, like whatever section is covered in a particular week. Because like this right here, what we just did, that was using the power rule from last week's lecture. Right. And so like all this stuff, all of these rules are just going to keep appearing. So it's like you really want to like know them. So it's not like a big stress when you come across them. You just come across them and you just know what to do, period. So so please, I will beg you again, please memorize these rules. So now we have our F, we have our G, we have our G, we have our F prime, we have our G prime, and we're going to apply the product rule now. So using the product rule, we say that we start off with F prime. This right here, F prime, which we just found is 4x. And then that's times our G, times G, which was the tangent of x. And then we have plus our F, which is this 2x squared. And then times our G prime, which is secant squared x. And look, we have our derivative of our numerator now. So now we get to go back to the quotient rule. So again, what makes this problem tricky is we're using both the product and the quotient rule. So like we're using the quotient rule first, but then we're like, in order to use that rule, we have to use product rule. So now let's plug everything in to our quotient rule. So again, quotient rule, it says that our derivative will be the derivative of the, I'm going to make it big. I don't know how big this ends up being, but I'll make a big fraction bar just to make sure we're good. So quotient rule says we're going to have the derivative of the numerator, which we just found was this F prime, all of that. Oh my goodness. So we have to put all of this in. It might be helpful to have the quotient rule in front of you so you're not so it doesn't feel so stressful. Here, I'll write it down right here. So it's very clear. So we have the derivative of a quotient, F over G is F prime G minus F G prime over G squared. This is a prime. So this is quotient rule. So this is what we're using right now. So it says first we take our F prime. which is all that mess, like what we just got. So I'm just gonna write it down. 4x tangent of x plus 2x squared secant squared x. So this is our f prime. Whew. And then this is multiplied by our g, which is this secant of x. I thought I was making myself a big fraction bar. It wasn't big enough, was it? So and then we have minus our f, which is all of this. Still a lot of stuff. Here's our minus our f. So 2x squared. I have to start writing smaller. Tangent of x, that's our f. And then times our g prime, which is all of this. So times secant of x tangent of x. Barely fit it in. And then that's all over my g squared. So again, my g was secant of x squared, when we generally put the square right where I put it. But it is okay if you put secant of x in parentheses and square the whole thing if you want. So at this point, I'm just going to write the answer. I'm going to type it in just like this. There are some things you could do, like you might notice that you have tangent of x times tangent of x, so you could write tangent squared x at the end of the numerator if you want. But I'm just going to type it all in as it is. Or maybe, you know what, maybe I will combine my tangent of x's. You could also, what else could you do? You could distribute that secant of x if you want. So I won't though. I'm just gonna type everything in. And again, I recommend that you, if you are simplifying something, so you're not required to simplify in this section at all. For the most part, I should say. Well, in this section, you're not required to simplify. And then most of the chapter 2, you're not required to simplify. But my recommendation, if you want to practice simplifying, because in chapter 3, we do end up simplifying and because we're actually working with the derivative. So if you want to practice simplifying in this chapter, it's fine. Just make sure that you keep your work, have all your work there, so that in case you make a mistake, it's it'll be easier for me to see where the mistake happened. I will say, even though you even though what was I gonna say? I forget what I was gonna say about simplifying. It'll come to me, I'm sure. Okay, so I entered it all just exactly as I had it, right? And then now we enter here. And for this f prime of 2, notice it's asking us to find the derivative when x is 2, which means we have to plug in 2 for x. So now I'm gonna go and plug in 2 for all of my x's. I just copied my answer for the first part, and now I'm pasting it. I'm sorry. And then I pasted it into the second part. Now I'm plugging in 2 for all of my x's. I know that 4 times 2 is 8, so I'm just gonna replace this with an 8. Although you could, you know what? No, I actually am going to multiply this by 2 because I just want to be really clear. I'm replacing all of my x's with 2's. But if you want to do some more math and in between, feel free. Like that 2 times 2 squared, you might know that you'd be like, that's 8. I can just put 8, Same thing here. I could just replace this whole part with an 8, but I'm just replacing every single x with a 2. And whatever that is, that's my answer, and it'll accept this, happily accept it. Because the point of these sections is not really for you to see that you know how to simplify. It's that you know what you know how to find the derivative. That's the point. So anyway, have fun with these here. There are lots of problems for you to try. And if you have questions on any of these problems, I bet there are questions on number 26, which is a really interesting problem. But yeah, come to our work session. Take care, everybody. Bye.